Hello. So in the last few slides, we had a chance to take a look at our different locations that we chose and how the amount of daylight varies according to the time of year in those locations. What we tried to do in this section of the presentation is bring our three variables together in one graph. So our three variables, of course, the dependent variable being the amount of daylight hours, but the two explanatory variables that we have are the location measured by the latitude and also the time of the year, the day of the year. So what we're looking at now in this picture is a view of locations in the northern hemisphere. So the black vectors, the black points on the graph represent Berlin, Germany. The blue ones, of course, represent Lexington, Kentucky. And behind that, the pink, we have Hawaii, a location in Hawaii. And what we see here is that as we move closer to the equator, as we go from 52.5 degrees latitude to about 39-ish, I think Lexington was, down to the 20-degree latitude in Hawaii, we see the amplitude of our sine curves get smaller and smaller. In fact, the blue points or vectors represent the location Quito, Ecuador, which is basically directly on the equator, and there you can see that they have constant amount of daytime, roughly 12 hours a day, a little bit more, 12 hours and 7 minutes a day. What is interesting, or at least hopefully insightful, when we rotate this around, we'll get a better look at what's happening in the southern hemisphere. And we see our sine curves turning. There you can see Quito straight across at 12 hours and 7 minutes, and here comes our locations in the southern hemisphere. Alright, so I'm going to try to stop it right about here, maybe a little farther. Yeah, and there we see basically the same patterns we saw before, but reversed. So we still see that the location farthest away, the light green, which represents a city in Argentina, which has roughly the same latitude as Berlin, but below the equator, has the highest amplitude of all of the South American cities, Southern Hemisphere cities. And we have our location, which is in orange, which is Melbourne, Australia, which is roughly equivalent to Lexington, Kentucky. And the yellow represents Lima, Peru, which has a 12-degree latitude in the southern hemisphere. Yeah, again, we see the same pattern, that the amplitude gets smaller as we get closer to the equator, eventually kind of approaching that totally flat Quito series of points. But we also see that the amount of daylight is inverted from what we saw in the northern hemisphere. So that what I mean by that is where there was a peak, we now have a trough, and where there was a trough before, we now have a peak. So yeah, that's hopefully a graph that shows us the relationship between all three of those variables that are under consideration for us.